Okay, so we're looking at mixed exercise 7 from the first year core textbook, and we're on question 18, so we're looking at proofs. And we're asked to prove that the sum of two consecutive positive odd numbers less than 10 gives an even number. So I'm not sure that's the best wording, but I think they mean that each of the odd numbers are less than 10. So quite often with proofs, we're thinking about algebra, but I think the key thing about this question is they're talking about odd numbers less than 10. So there isn't many of those, there's only 5. So this is an occasion where proof by exhaustion is really going to be the best way to go, because it is very feasible just to show all the different circumstances of this. I mean, particularly as it says consecutive. So the only options are going to be 1 and 3, 3 and 5, 5 and 7, and 7 and 9. Okay, so that's just 4 calculations. So that's going to be way quicker, actually, just showing that it works for all of them, rather than try and do algebra. I mean, so we could quite easily do it algebraically, because obviously the less than 10 is kind of irrelevant. That does work for any pair of odd numbers. They don't have to be consecutive. So any pair of odd numbers would give you an even number. So you could do an algebraic proof. This is a nice example of one of the rare occasions where proof by exhaustion is actually really, is doable. So you always need to write a conclusion, though. So so these are, often the conclusion can take longer than the proof. So these are the only pairs of consecutive odd numbers less than 10. And all of their sums are even. Okay. I'm assuming they've done it by exhaustion. As I said, you could have done it algebraically, yeah, so just to show you, as there's only 4 instances, to show that it works for all of them.